Okay. We are live, I believe. Let's let a few people join the broadcast. But we are back with the Chainlink Fall Hackathon. We have Rahat from Polygon here, who is going to give a demo on building better UX in Web3. And Rahat, I'll let you take it away.
Awesome. Thank you. I'll go ahead and share my screen so we can get started. Okay, cool. So yeah, today we're going to be talking a little bit about improving UX in Web3. It is a topic near and dear to my heart. And before we dive into it, just I guess a little bit about me. My name is Rahat. I am the lead developer relations engineer over at Polygon. And previously, I've throughout my career, been a front end engineer, which is where I guess some of my UX kind of like side of things come into play. Been a freelance Solidity engineer before eventually moving into DevRel. Overall, I've been an indie hacker / Web3 enthusiast. So tried to build a couple failed startups, never went anywhere. Can always tell you about things that go wrong. Can't really tell you what went right, but always happy to chat about that kind of thing. Really quickly, a little bit about Polygon, just in case you're not too familiar. Polygon is one of the leading platforms for Ethereum scaling and infrastructure development. So we provide a bunch of different solutions. We're kind of trying to be like a Swiss Army knife for Ethereum scaling. So you've got different solutions like ZK rollups. We've got a lot of things on that side of things coming through in the coming months, as well as optimistic rollups, side chains, and more. But there's different solutions made for different problems, and we're trying to provide all of those different use cases something to build on top of. And that kind of leads into this next question, right? We talk a lot about adoption through scaling, but what else can we do? Not only is Polygon working on this space, but there's a lot of different protocols companies that are working on improving scaling Web3, driving for mass adoption, and eventually, getting more people to use, our products in the Web3 space. But adoption is only going to be easier if I can use your dApp quickly and easily. And those are the two main things I want to kind of like focus on. How quickly can you get a user onboarded onto building on top of your dApp? And how easily can they use it? So the questions to ask yourself about your dApp when you're, trying to look at these kind of issues. How comfortable are your users with connecting their wallet to your dApp? That's where it starts. Are they given a choice to connect? And we're going to dive into this in a little bit. What is the onboarding flow for using your dApp? For using your dApp, do they need to go on some exchange some fiat for, some ETH, for some Matic, for whatever it is, and then make sure they have that for gas fees, for transaction fees, etc. Maybe you want to consider that although is the approach right now, that's probably not the best approach. We're going to go into that too. And lastly, how fast is your dApp? We know that, not all, no matter what blockchain you're using, whatever chain you're on, there is, that little bit of like time needed to like get a transaction to finality, right? No matter how quick it is, it's not instant. So how do we improve on the UX of using your dApp despite that limitation? So those are the few things that I mentioned. I want to start off first with wallet connections. Wallet connections are where your users begin to start interacting with your product, right? This is where they give you access to, or where they start to get access to doing actual transactions. If it's a DeFi app, for doing, well, everything's a transaction, but just really doing anything, any type of interaction with your dApp starts with a wallet connection. On the screen, I have just some basic wallet connect function. This is React based. As I mentioned before, I was a front end engineer. A lot of my experience comes from the React world, but I'll explain this really quickly. This is just a regular kind of like, and none of this specific code is like React specific. This is all JavaScript. But what's happening here is that I'm checking if the Ethereum object exists in the window. If it does exist, I'm using the ethers.js package, which I didn't show was imported, but is imported in this code file. And I am essentially, sorry about that. 1 second. And essentially, I am going to connect to this wallet, get the permission to connect to the wallet, and I'm console logging out an address, right? Nothing too fancy going on. I take this address, I slap it onto a button. Whenever you click that button, you connect your address. Really quick way of like what that looks like in person, in practice. You hit connect wallet, MetaMask pops up, you choose an account, connect, boom, you're done. Very basic, but it's very important to like really focus on a key factor here. The user had to go in and click a button, right, to get connected, to get that permission. We get that consent from the user. Here's another wallet connect pattern that sometimes happens. This wallet connect pattern, this is again React specific code. This is a use effect. This use effect is going to run whenever this specific component or page loads, right? So as soon as you hit the page, some functionality is going to run. In this case, I have my handle wallet connect I showed you here. So this handle wallet connect function is going to run as soon as you land on the page. In one case, you might say, hey, this is great. Now your user doesn't have to click a button. Now your user doesn't have to, even think about connecting their wallet. Please don't do this. This is a tweet that I put out like a while back before I was talking about this specific issue in another conference. But, pet peeve that I have is like just being asked to connect my wallet as soon as I land on a page. I should be able to look around and decide if I want to connect first. What am I connecting to? Unless I really know you, 9 out of 10 times, I am not going to use your dApp in this case. And the thing to kind of like remember here is just like, look, if you're scrolling the internet, you go on a web page, some music immediately starts playing. Some, video immediately starts playing. That's not good UX. Like Google will actually, give you some sort of like deranking in SEO if you do something like that. So it kind of like works the same way. Why are you not giving your user consent to actually connect their wallet first? So that's the first and foremost, the first thing to do in building a better UX. You build trust between yourself and the user, allow the user to make the choice. Now, a lot of people try to justify not doing this with something called the 3-click rule. The 3-click rule states that, after 3 clicks, someone loses interest, someone is no longer going to use your application or whatever it is. And there is absolutely no data, no actual hard data backing up this rule. This is kind of like a fantasy rule. And the main thing to like understand is like not all clicks are created equally, right? If we're coming from, you're trying to onboard new users from like a Web 2 kind of space into Web 3, a lot of these folks are already used to logging in. Logging in is something that we do anyway. In this case, the Connect wallet is almost taking over that login feature, right? You can extend the Connect wallet to go further and do login with Ethereum. We're not going to go like fully into that side of things, but some level of authentication is already expected from the user. So that's an important thing to keep in mind here. Removing clicks, removing this supposed barrier is not actually improving any UX in your app. What you're actually doing here is removing consent from your user. So you have to make sure that they consent to actually connecting, to authenticating, and being a part of your ecosystem. Next up, your user's connected, great. They try to connect. But here's the thing, right? Not all dApps are on the same network. They might be using a dApp that's on the Ethereum mainnet or another EVM compatible network or wherever. And then you need to get them maybe on Polygon because that's where your dApp lives right now. This is a wonderful little pop-up that comes up when I try to connect my MetaMask wallet sometimes on a place like Polygon Scan, where everything is on Polygon, and this little pop-up asks me like, should I allow this site to switch my network, right, from Ethereum mainnet over to Polygon mainnet? If I were to just click on some dApp, nothing happens. I don't get any feedback. I don't know that it's not working because I'm not on the Polygon network. I'm just going to assume that the dApp is broken. It's not usable, even though it is. I just have to switch my network. We need to make it as easy as possible for people to use your dApps, right? So this next part is like make switching the network as easy as possible. If you're going to be using something like either JS or using doing this at the with browser injected wallets, you can do something like using the window.ethereum.request method, and just giving it a bunch of filling out the details of the RPC, the exact chain that you want, the chain ID, etc. These are all things you can just grab from online, but get the user onto the right network. Most of this here is just boilerplate code you can just Google, so it's not anything too out of the ordinary. We're just filling out a bunch of things. So the last kind of thing I want you to think about and further considerations for wallet connections, because again, this is the most important part. This is the entry point for your users into your app. Don't just focus on browser wallets. I know in this specific workshop and example, I'm giving you very focused browser wallet type of examples, but keep in mind that not all users are using browser wallets. People like using mobile wallets. People like using hardware wallets. People like using different types of wallets. Abstractions are very, very nice. Consider using things like Rainbow.me, the Rainbow Me kit, Wallet Connect in combination with things like WagMe React hooks. These are all really awesome open source tools that are great for making your user experience a little bit better. These will provide you not only a good UX, but also a nice little UI pop-up for actually connecting to the different potential wallets that someone can have, and also provide you with functionality for easily staying connected to them and keeping track of your users, so you don't have to do things like writing out this full request or writing out this full handle wallet connect logic here. A lot of that is done for you. They have reusable hooks inside of the React WagMe library. So definitely consider, not only upgrading the experience for your users, upgrading the experience for development for yourself when building out these products. And I can't reiterate this last point enough. Please remember, let users choose to connect. Super, super important. Now let's talk about the waiting game. Waiting. So sometimes when I'm doing a live demo, when I'm live coding for a workshop, or if you're trying out some new, dApp for the first time, a bunch of the time you're going to spend waiting. You're waiting for a transaction to be completed, a transaction to be mined, a transaction to be finalized, whatever. And a way to kind of get over this hump a little bit of having to wait for so long for all of these transactions to actually finally go through is doing something like implementing optimistic UI patterns. What is an optimistic UI pattern? It's really just the act of giving your user feedback when something is happening, right? So sometimes when I an example that I kind of like to give, when I go into online to check my Amex account to pay my bill or do something like that, a lot of the thing I see with the website is that there's a skeleton loading, right? Whenever I navigate to my transactions, whenever I navigate to the place where I want to pay my bill, and although internally something is happening where they have to hit some API to get some information, display some data, which is taking a moment to actually do. You see that the website is giving you feedback. That skeleton that is loading is showing you that something is happening, that you're waiting for some data to come in. Optimistic UI patterns doesn't mean just like throw something out there and like, put something on the screen and pretend everything was working great. No, it's really showing the user that there is something in the background happening, letting them know that they just need to wait for a second. And that does actually give the feeling of a faster application, because the application itself is running. The application itself is doing exactly what you need it to do. We're waiting for some external source. So let's take a look at this like really quick example of like an optimistic UI thing. So this is like one of the very first smart contracts I ever wrote. It's actually, so I'm going to start with the demo, then we'll go into a little bit of code and this is just like a battle, Pokemon battle between a Charizard and a Lugia. So let's play this real quick and just to show you. So there's some attack functionality in here. I hit the use flamethrower, my MetaMask pops up, I pay some amount of gas, hit confirm, and you see that while the transaction is mining, the Charizard is attacking. So you see that, an action is taking place, right? I told, I clicked on use flamethrower. I see a little animation of a Charizard using flamethrower. In the background, the transaction is pending and has not been finalized. Nothing has actually happened yet, but it's going through. And I understand that because visually I can see that the Charizard is now attacking. So it's really giving these cues, giving these cues to the user, showing them that the thing that they want to happen is happening. So going over a little bit of code, this is just like the basics of like connecting to a contract. You start with your contract address, you bring in your ABI provider. Again, this is like Ethers.js specific, getting the signer, and then providing all of those values to connect to the contract using the ethers.contract method. And this is kind of like where the function, where the magic happens, right? In JavaScript, I have this attack function, right? The attack function uses all of the functionality that is inside of the Lugia battle contract that we just saw. And here's where like the magic really happens. In JavaScript, we use this async await pattern to actually wait for like asynchronous functions that need to happen externally to go through. Before and after these await functions is when we can actually say, oh, okay, while we're waiting for the attack to happen, play some animation, make some state change on your UI, show the user some feedback, maybe give them a pop-up or a toast or something that says your transaction is pending. Something as simple as that is fine. Main thing to kind of remember in this specific point is that distractions and updates are your friends. Distractions and updates will give the user the perception that your app is moving quickly, moving fast. I see the same sort of pattern being used on new apps. One example I see on an app called Orb. So Orb is a mobile app for like building that's built on top of Lens protocol. And one of the things I see in there is like whenever I post, I see a little green dot like next to my post showcasing that it is going through. But I see the post there as if it already went through, right? But there's still that little green pending dot showing me that while it's not fully through yet, I can still keep using the app. I can still go through and know that the app is still like making sure that specific transaction is still is processing. Let's take another look at this through Uniswap. Uniswap does like a super good job at this with a very, very basic UI, right? So this is nothing but a form. It's a little box where you want to swap some tokens. So I put in one Matic and I want to swap it for some USDC. I saw that, so I'm going to pause it here real quick. So you'll see here, I keep failing to pause it at the right moment. Okay, there we go. You'll see here that when I put in the Matic and I put in the USDC, I automatically get some feedback that something is going on in the background. We're fetching the best price, right? So I automatically know that even though I can't like hit swap or do anything, that something is going on in the background. Something is like that I'm waiting for some information. And then the information populates. Now I know how much my one Matic can get me in USDC at this point in time. So then I decide, okay, great. I want to go ahead and initiate this swap, right? So I go ahead and click the swap button. I hit confirm. And this whole time, you'll see that in the background, I have to go through and like actually approve everything on MetaMask. But at the same time, I get feedback from the actual UI itself saying that there's something that needs to happen. We're waiting for confirmation. Confirm this transaction in your wallet. You're giving the user feedback that they have to do something. What if for whatever reason they don't see their wallet pop up? They can go into their wallet now and look at that notification. So you're helping the user along the way in this journey into doing this transaction. This one single transaction has several points in it where you can give feedback to the user. Starting from here, we're just letting the user know that they need to go into their wallet to confirm. So we go ahead and decide, okay, I'm going to approve this transaction. Hit confirm. Transaction is submitted. Great. So this is an immediate bit of feedback that the user gets, that the transaction is submitted. We can go on an Explorer and actually, check out what it is. I can even add USDC to my wallet. At the same time, I have this little pending button over here showing, yes, that it's still pending. So even if I decide to close out this box, I know that it's still pending because of that little bit of UI feedback up here. So eventually, once everything goes through, I can go ahead and close this out and start doing other things if I wanted to. The UI doesn't just stop because we're waiting for the transaction to keep going through. I can still use the app. I can explore other things. I can look at different pools. I can look at different swaps. I can look at charts. I can do anything else I want because I know the feedback that was given to me by this app is that my transaction is pending. It's still going to go through. So, whoa, we just went back several slides. So talk about Uniswap. Your distractions and updates, like I mentioned before, they happen before, during, and after your asynchronous function calls. So whenever you make an asynchronous function call, something that needs to happen at an API, something that needs to happen on chain, something that needs to happen outside of the scope of your UI, where you need to wait for something else to update, this is where you put in your distractions. This is where you put in your updates. This is where you communicate with your user. So now we looked at the front end, right? We looked at what you can do on the front end side of things for improving your UX, but there's other things you can do as well that goes beyond just the front end. And I want to talk here about like how Polygon can help to like really supercharge the UX of your dApps. And one of those things that really helps with onboarding users onto your applications, with making it easier for users just to like do what they want, on your application is gasless meta transactions. So I have a really quick, very poorly drawn map here. I'm going to go through each of these points and then I'm going to break it down a little bit further. But how does gasless meta transactions work? The thing to kind of remember with gasless meta transactions, and the thing I want to say off the bat, is that they're not exactly gasless in the sense that no one pays gas for them. In this case, what you're doing is that the developer or the protocol company is paying some amount of gas upfront or have some budget for gas to be paid on behalf of the user, right? And to understand this, we're going to go into a little bit about signing transactions, specifically with EIP 712 with structured signed data. What we do is like when we sign a specific transaction, that transaction is sent to some relayer. Some very popular ones are Biconomy and Open Zeppelin Defender. That relayer, what it does is it accepts that, that transaction, that signed data, it wraps it into a request, and that request can be loaded with like the amount of gas needed to actually execute the transaction. That transaction is sent to the contract, And on behalf of the user, you now execute that transaction, paying for their gas for them. So let's talk a little bit about EIP 712. So EIP 712 essentially allows you to sign structured data. You can sign data pretty easily, like from your front end, if you're signing some transaction. Signatures in Ethereum are built in, and this is a whole like rabbit hole that you can dive into, but signature, but you can kind of like look at the Ethereum blockchain itself as just like a whole bunch of like signatures, a whole bunch of like data that's been signed by a person. In the terms of transactions, those signatures have some monetary value added to them for gas, for anything else. In this case, we just want a signature verifying that some user wants some bit of data sent to some endpoint. So on your front end, you can design that to be like a JSON object with like maybe details about certain arguments that a function would need, or details about like the user themselves, etc. And with Ether's JS, an implementation that helps you initiate that signing of the data is this underscore sign type data. So the reason there's an underscore in it for now is because theoretically it is still kind of like experimental, I guess. And there's still like some updates on the actual API going around. So eventually this won't have an underscore next to it. But I think that the underscore version will still always like be there just for like backwards compatibility. So if you're ever using this sign type data method with Ethers, just know that you should be okay keeping it underscore. You don't have to like remove the underscore in the future at any point. But from the JavaScript front end, you create the signature and you ready it to be sent to some HTTP endpoint for a relayer. The relayer, you go through the documentation on like OpenZeppelin, Biconomy, Ethereum Gas Station, whatever you want to use. Usually what you're doing is like you're just setting up some endpoint that you can hit. You'll probably be loading it up with some funds for gas, choosing like the network that you want it to be on, etc. If you're using something like Biconomy, I know Biconomy has a lot of really good docs that show you like how starting from your smart contract, you can use certain EIPs to like make your smart contract kind of like relayer friendly from the beginning. If you don't do that, you would have to rely on something like EIP 7112, and there's documentation on the Biconomy side that helps you with that as well. But essentially, like you make the signature, have some data, you send it to this relayer. The relayer will load it up with the gas, right? We just make a request to some endpoint, and that's it. Now you can do something like having like an actual free NFT mint, where like let's say the NFT is free and your users don't have to have any money in their, or like any tokens in their wallet for actually covering the gas fees, because you're covering the gas fees for them. This is an incredible way to onboard new users into your ecosystem, into your dApps, because one of the biggest friction points for Web2 kind of like users to like get into Web3 is the fact that they have to go on some exchange and have some small amount of funds just to like initiate a transaction, to initiate some interaction with your dApp, right? So making that as easy as possible. You can use this like even just implement a sort of like a try before you buy type of deal with your application, because that doesn't really exist in the Web3 world. No matter what, you need some funds to cover it. And one really, really good example of how this has been implemented that's out in the wild right now is with Lens Protocol. So Lens Protocol, I kind of mentioned before, some apps that are being built on top of it, like Orb, some others like Lenster, or whatever. And all of these are all, whenever you're using Lens, like all of your likes, your comments, your posts, all of that is saved to the Polygon blockchain, but you don't actually have to pay for gas for any of those. Now you don't even have to sign every single transaction anymore, because a lot of those transactions are batched together. So what happens is like something like this enables you to create almost a Web2 like experience with a Web3 app. And that's going to be a major factor in how you actually onboard more users onto your ecosystem. So this is all really making sure that you have the key ways of like how you can improve UX within the dApp, not only on the front end, but the usability on different levels as well. Something like this with like the gasless meta transactions, super economically viable on something like Polygon. Doing this on like Ethereum mainnet, you would like run into like you would like burn through your runway very, very quickly, paying for gas fees, especially if we go into like another bull cycle. So, using scalable solutions to, improve on things like gasless transactions to onboard your users more quickly, giving them feedback and everything like that. As I mentioned on the front end side, these are key things that you can do to make the UX of your dApp a little bit better. So it's more user friendly for people outside of just our bubble and niche of like Web3, native folks. If we want to grow that a little bit bigger, these are some of the things that we absolutely need to do to make it easier for more folks to come into the space. And some other things to explore. There's a lot of different things to improve on the UX side, more than like I can really put together into one single workshop, because it'll require like a lot of like deep diving. One thing that many folks are talking about right now is account abstraction. And I highly, highly recommend looking into account abstraction, because this is kind of like how we improve UX even further. I'm sure many of you as developers, you've like had the experience possibly of like, oh no, I just committed my private keys to GitHub, or even just like just like the act of just like keeping this like gigantic seed phrase written down somewhere for you to import your wallet in different places. It's not very good UX, right? What account abstraction is aiming to do, and I'm not going to like deep dive into it, but I want to kind of like mention it, is like doing things like building smart contract wallets, right? Smart contract wallets where, possibly you have social recovery if you've ever like lost your private keys, the ability to update your private keys, the ability to, abstract away just a lot of like those friction points with using Web3, with some of the unfortunate side effects of like what happens if you lose access to certain things. And definitely recommend diving into account abstraction some more. I'm working on a few more workshops moving forward where we dive into that side of things. That's going to be kind of like the part 2 to this type of workshop. So definitely keep yourself tuned for those type of things. And just as the last thing, again, my name is Rahat, over at Polygon. Always open to talking through UX, asking, helping people build. I'm usually at a hackathon or event doing these type of workshops and things like that. So if you ever see me out in the wild, please definitely say hi. If you enjoyed this workshop, please let us know on Twitter. We are 0x Polygon Devs, and you can also tweet at me at Rahat Codes. So thank you. Really enjoyed being able to come up and do this. I'm going to go ahead and stop sharing, and I'll check out the questions if there are any. Cool. I like that you guys are not ignoring the basics. It's helping a lot. Awesome. Cool. If you do have any questions, I'll leave it open just for a couple minutes, just in case. But if not, we can probably wrap up here.
Yeah, Rod, I think it's safe to end the stream.
Sorry, I think my audio was muted.
I think it's safe to end the stream. So
Okay.
I'm going to go ahead and end the broadcast. Thank
Cool.
you.
Yep. Thank you.